I'm excited about this one. Hello YouTubers, this is the noobifier. Star Citizen's been waiting for the God patch. In Star Citizen, based on how development is progressing, I feel that it's unlikely we'll ever get one magical patch that fixes everything. That's not to say that progress isn't being made, more that based on how complex the project is, as things are added, they sometimes break things that used to work well. Recent patches since 3.0 have improved frames, giving us a look at the future performance and reassuring parts of the community. Prior to these optimizations, frames in the persistent universe were crippled by the lack of any real optimization. It wasn't until I tested an offline state way back in patch 2.5 that I saw how beautiful the game could look. The motion blur, lighting, dust, smoke, vapor trails, reflections, they all made sense for the first time. It was a real revelation, and only those who backed before 3.0 will ever have an appreciation for where we are now. The reason I mention all this playing offline is that the network was the bottleneck, and now I see server-side OCS as the next limiter. Now that we have client-side OCS, server-side OCS was said to be the part that's going to let the game development kick into high gear. As improvements are made though, the size of the universe expands, either in ship sizes, player caps, or the locations we can travel to. You can never have it all. We keep adding more and more without addressing core tech. This is going to hurt performance, and eventually we'll be back to a slideshow. We're expecting microtech this year, but according to what we were told on some RTVs and ATVs in the past, we do need server-side OCS first, and that's not on any roadmap. The 890 jump being such a large asset, for example, some have suggested that it might have been smarter to hold it back until server-side OCS was working. Jared, I don't presume to tell you how to do your job, but what I'd like you to focus on for ATV is a 20 to 25 minute interview with whoever's best to answer the questions, plus Chris Roberts, in the format of Calling All Devs or 10 for the Chair. Your choice, and I assure you, it'll be the most watched and most useful topic that you publish this year. Moving on, and regardless of all of that, I'd like to break down some of the terms used, what they mean, and what the systems are supposed to do. This took a chunk of time to research, so if you got something out of the video, please do me a solid and share it with your friends or org mates. Let's begin. OCS is short for Object Container Streaming. To understand OCS, we need to define an object as anything in the game. A container is defined as a group of objects that form an area. A container could be a solar system. Containers within the solar system could be entire planets. Containers within the planets could be the landing zones. Containers within the landing zones could be the individual buildings or individual rooms. Containers reside in other containers. They're set in a logical order and hierarchy so they can be streamed in and out as required. Streaming is the last letter in the acronym, and it's the act of making or breaking by loading or unloading containers full of objects. Parts of a whole can also be brought in as required. Asynchronous background spawning, or ABS, is a further optimization in OCS. ABS is designed to reduce the microstuttering that might occur when very large groups of objects are made or called from memory all at once. These all work together, and in researching for this video, it became clearer why these systems are taking so long. They touch on everything in-game and would likely need to fully replace whatever systems we currently are using. So, OCS aims to manage the state of the objects by preloading and unloading automatically as needed and on time. Parts of this work on the client side already, but we're waiting for the server-side OCS. Each player requires you need objects to draw their individual areas, even if they're within close proximity to each other. You could be at the aft of the ship, looking rearward out a window into the vastness of space. I could be in the mess hall of the same ship, 20 meters starboard from you, without any windows. Each of our scenes require unique assets, but the real trick here would be when I decided to leave my room and join you. The system would need to stream the required objects to construct what you're currently looking at for me. As I leave the mess hall, the door opens, and what was needed behind the door would have been called up, assembled with textures, lighting, sounds. As I walk through the door closes behind me. The system needs to decide whether or not those assets are retained or culled from memory in an attempt to improve my performance. This is done seamlessly, and that's the trick. Objects on demand, on time. If I change my mind and turn around, the system needs to be ready to reload and reconstruct where I was. It sounds simple, but I'm sure it's a bugfest nightmare at the scale required to build Star Citizen. Server meshing is another term passed around a lot lately, as the end state of the game is to have no player cap. Server meshing allows objects to be passed between individual instances. Instancing a server is a way to manage a load. In Battlefield or Call of Duty, an instance could be seen as the individual game that you're in. Friends in your party join a game, others load in, and the game starts and then ends. rinse, repeat. Instances in Star Citizen need to be dynamic and persistent, and this needs to be oblivious to the player. No load screens once you're loaded, and that was the pitch in 2013. Imagine you have two freelancers parked in space back-to-back, stationary with their doors open. The players in each freelancer can see the other players. We already know that they are each a local physics grid, but depending on how the server's built, they can either be in the same instance or in separate instances. It really doesn't matter how the system handles the traffic, as long as the two players are oblivious to it. The code needs to be able to seamlessly hand off assets as players go about their business. One of the players could decide to float over to the other, throw a box, or even open fire. My example changes a little bit as we escalate the example to a pair of javelins, or a populated city district at ArcCorp, which each themselves could be tens or hundreds of instances. I like to picture the game servers like bubble tea at the bottom of a very large cup. The individual beads are suspended in a liquid. The beads are the instances, and the cup fills up or is emptied as needed. Players can migrate between the beads, oblivious that they've actually changed servers. They can bring, remove, or destroy objects, which would need to be tracked and represented to anyone else within the vicinity. Two ships dogfighting above a planet may be in an instance, as a larger ship leaves atmosphere and passes by. Does the system keep them separate, or does it let the large ship pass into the instance and then leave? From the perspective of the players, it really doesn't matter as long as it doesn't break immersion. All this is really cool. I'm about done because I feel that I've met the aim of this video. It's my understanding that Star Citizen isn't the first to use any of these concepts within the industry. It's also my understanding that the reason that our game is unique is the scale of the assets, the detail in the objects, and the size of the sandbox. I learned by researching for the video, and then we all learn more with your added input and questions in the comment section of this video. Thank you very much for spending your time with me. Hopefully we get an update about the status of SSOCS, and you already know that I'm ready to break it down for you. Fly safe, and I'll see you in the verse.